Welcome. To locate objects which you have trouble finding, you may use the command Z-E or zoom to extents to zoom in the current viewport for it to cover all visible objects. In this case, the visible objects are situated so very far away from each other that we don't see them in the viewport. So let's hold Ctrl and press A to select all objects, and then we can hold Ctrl and click and drag to make a deselection window and deselect everything to the left here. We see here that we had some objects, one curve and one surface, that were removed from the selection, and now we may use ZS, zoom to selected, to zoom to the missing object. Here we have it. It's located very far from the origin, so these shading errors or artifacts occur. Even if Rhino has an astronomical capability for large numbers, distant coordinates and high precision, for very distant objects these sort of shading errors occur due to precision errors, so it's always better to work relatively close to the origin. Let's move this object with M and move it from this corner, and then a nifty thing in Rhino is that the origin, it can be input as 0, 0, 0, but that is the same as simply inputting 0. 0 is totally sufficient for the origin. Enter to move. Let's zoom to the still selected object, and here we have it, and the shading artifacts have disappeared. Very good. You may use the Gumball tool to quickly transform objects. With Gumball active and the intention to transform these two corners, we can do it in a couple of ways. Either we do solid points on, and any selected object will have their surfaces edit points available for selection. So we can select this one, and holding Alt to disable dragging and Shift to add selection, we can add this to selection as well. And then we can simply use the X-axis translation or movement arrow here to move these two surface edit points 2400 millimeters here. Instead of using solid points on to make these corner points eligible for selection, we can also, by hitting escape, disable the visibility of these edit points, and then we can directly select them with Ctrl and Shift. So we can select that polysurface vertex there, as well as this here. And then we can move these, -600. To quickly verify the dimensions of any object or any selection of objects, you may select the objects and then type BoundingBox and enter to activate the command, and enter again to confirm the output and coordinate system. Here stated are the minimum and maximum coordinates of the whole boundary of any selected objects, as well as the dimensions in all three X, Y, Z axes, so the length, the width and the height. To delete the bounding box, you may simply Ctrl Z to undo. Having confirmed that the dimensions of the objects correspond with a scale of 1 to 1, to scale it down to any scale, let's say 1 to 200, it's very easy to do scale, and then since we move this object so that this corner is located precisely at the origin, we can simply type 0 to define the origin as the base point, and then the scale factor you may input as a fraction, so 1 divided by 200 if we want to have a scale of 1 to 200. Perhaps easier to input than the decimal value of 0.005. Let's zoom to selected objects to make our view fit the selected objects. One thing that is good to remind oneself of is that even though the edges and isocurves of these surfaces in this polysurface represent the BRep, the boundary representation of the mathematically perfect objects, the surfaces that we see here for any shaded display mode are actually meshes. These meshes are proxy meshes representing the surfaces as well as it's set to do. If one select the objects and type extract render mesh, and then SelLast to select the most recently generated selection set, we see here that this mesh is quite sparsely populated with edges. For a mesh, any curved surface must be subdivided into triangles, and it is the density and position of these triangles that make the mesh more or less resembling the original BRep. In this case, if we go to the Arctic view mode, we clearly see here that the native render mesh has some severe issues. As such, for visualization or 3D printing, it is advisable in any scenario like this to generate our own mesh. Let's go back to Shader, and we can select the BRep here. If we type in the command mesh, we see here that we have a lot of different settings. These can be replaced with simple controls like this, but in the detail controls you have of course more control. It is advisable to experiment with these settings because there is not one recipe that is the best for all kind of objects. So experiment with these different parameters. For this specific object, these settings worked out fine. Let's hit OK. And SelLast to select the most recently generated selection set. And then we can move this all the way here perhaps. For a very quick visualization, the Arctic display mode is recommended. One thing to remember here though is that the floor of the Arctic display mode is automatically adjusted depending on the objects in the scene. So in this case, if we select everything with Ctrl A and ZS to zoom to selected, we see that we have this giant question mark here, and in this case the floor and ambient occlusion are generated here instead of where we want it. So let's simply hide these objects with Ctrl H or hide. And then we can select our objects intended for visualization again, and then zoom to select, and now we have proper floor placements and ambient occlusion. Let's position our view here, perhaps something like this. And then we may type in the command ViewCaptureToFile. This is very, very nifty. The transparent background here was already checked. If it is not checked, you get the actual background in the image. If you set the output file format as JPEG in the next step, then the transparent background will not be properly implemented, since the JPEG file format lacks alpha or transparency. If you have transparent background checked, and here you can adjust the scaling of the image. If you have the scaling as set to 1, you will get the same resolution as you have in the viewport, but you can very easily upscale it, perhaps by a factor of 3, creating a more high resolution image, and then we can click OK, and we can save this here as a PNG. If we now maneuver to any preferred image manipulation software, and then we can go to where we saved the output image, we can click and drag this into the image manipulation software, and then we can perhaps with Shift S here in GIMP, we can with scaling move it here. Perhaps the perspective is a little off, that is of no consequence for this tutorial, but we can do it perhaps like that, so scale it up a little like that, and here we have the very, very quick visualization with the ViewCaptureToFile command in Rhino, ready to be inserted into any background image. We also clearly see here that the BRep with its native render mesh, which is the same as the extracted render mesh here, has these sort of visual artifacts, while the mesh that we generated with custom settings is without any artifacts. Thank you for your time.